Welcome to The Explainer. Today, we're getting into the incredible biological engine that powers literally everything we do, from our heartbeat to our posture to just staying warm. It's, of course, the muscular system.
I mean, really think about it. Every single thing you do, the automatic beat of your heart, the decision to get up and walk across the room, it's all driven by this one amazing system. So today, we are going to pull back the curtain and see exactly how it all works. Okay, first things first. When we hear muscles, we usually think of, lifting things, running, just moving. But that is barely scratching the surface. Their job description is way, way bigger than that. They are absolutely essential to our survival. And just look at this list. It's pretty incredible. Sure, you've got movement and posture, the obvious ones, but they also stabilize our joints, which is what keeps them from popping out of place. And get this, they generate a ton of our body heat. That's actually why you shiver when you're cold. It's your muscles firing off tiny contractions to warm you up. Plus, they're the silent workers inside, pushing blood through your veins and food through your gut. It's a nonstop 24/7 operation. So, how in the world does one system handle all these different jobs? Well, it doesn't. It has a team of specialists. There are 3 totally different types of muscle in your body, and each one is perfectly built for its specific role. And this table just lays it out so clearly. First, you've got skeletal muscle. This is the stuff you control, the muscles you use to lift weights or go for a run. Then there's cardiac muscle, which is only found in the heart, and thankfully it's involuntary. You do not want to have to remember to make your heart beat. And finally, you have smooth muscle. This is another involuntary player, the quiet workhorse lining the walls of your organs, like your stomach and your arteries. Okay, let's zoom in. We're going to focus on one of those skeletal muscles, like your bicep, to see how it's put together. And the design is just brilliant. It's kind of like a thick rope made of smaller ropes, which are themselves made of even smaller threads. It's a bundle of bundles. So here's how it's layered. The whole muscle is wrapped in this tough outer coat, the epimysium. Inside that, you have groups of muscle fibers bundled together into something called fascicles, and each of those bundles is wrapped in paramysium. And then, if you go even deeper, every single muscle fiber has its own delicate little wrapper, the endomysium. This incredible structure is what allows you to have fine motor control. Your brain can choose to activate just a few fibers for a small movement or all of them for a big one. All right, now we're getting to the main event. We are zooming way, way down, past the bundles, past the fibers, all the way down to the molecular level. This is where we get to see the tiny, microscopic dance that makes every single movement possible. This is where the real magic happens. And to understand this dance, you have to know about the sarcomere. The easiest way to think of it is as the smallest possible engine inside your muscle. You have millions and millions of these little engines, and when they all fire up together, that's what creates force. Now, inside this tiny engine, there are 2 main parts, 2 key proteins. The first one is called actin. Just picture actin as a long, thin rope, or a track. It's basically the thing that's going to get pulled. And who's doing the pulling? That would be our second protein, myosin. Myosin is the motor. It has these little heads that are perfectly shaped to reach out, grab onto that actin rope, and give it a good tug. It's the engine's power source. So this all comes together in what's called the cross-bridge cycle. It's a simple 4-step process. First, the myosin head, which is loaded with energy, latches onto the actin rope. Step 2, it pulls. This is the power stroke, where it pivots and yanks the actin filament forward. Step 3, a new energy molecule, you might have heard of it, ATP, comes in and binds to the myosin head, which makes it let go of the actin. And finally, step 4, the myosin head uses that ATP's energy to snap back into its ready position, ready to grab and pull all over again. And this happens thousands of times a second, across millions of sarcomeres. It's unbelievable. And the fuel for all this incredible action? That's ATP, our body's energy currency. And our bodies are just amazingly efficient at making it. When there's enough oxygen around, through a process called aerobic respiration, a single molecule of glucose can be turned into about 36 molecules of ATP. That's a lot of fuel to keep those little engines running. Okay, let's zoom back out. We've seen the molecular action, but how do all those tiny pulls add up to a smooth, useful movement, like waving your hand? Well, the secret is teamwork. Muscles almost never work by themselves. So for any movement you make, there's always a star of the show. We call this the agonist, or the prime mover. It's the muscle that's doing most of the work to create that action. So when you do a bicep curl, your bicep is the agonist. Simple enough, right? But every star player needs a partner, and that's the antagonist. This is the muscle that does the opposite action. Now, that might sound like it's working against you, but it's actually crucial. It provides control. It gently resists the agonist, which is what gives you smooth, precise movements instead of jerky, uncontrolled ones. Here are a couple of classic examples. To bend your elbow, your bicep is the agonist, and your tricep is the antagonist that controls the movement. But then, to straighten your arm, they switch roles. Now the tricep is the agonist. Same thing happens in your legs. Your hamstrings and quadriceps are constantly working together in this beautiful system of checks and balances. Now, all this pulling is great, but it wouldn't do anything if the muscles didn't have something to pull on. And that, of course, is where your skeleton comes into play. Together, your muscles and your bones create this incredibly sophisticated system of levers to turn all that pulling force into actual, useful motion. And what's really cool is that our bodies use 3 different classes of levers to get everything done, from something as simple as nodding your head to lifting something heavy. Let's break it down really quick. A first-class lever is like a seesaw, right? The pivot point is in the middle. That's what you're doing when you nod your head. A second-class lever is more like a wheelbarrow, where the load is in the middle. An easy example is when you go up on your tiptoes. But the one you use most often is the third-class lever. That's where the effort is applied between the pivot and the load. And a classic bicep curl is a perfect example of that. So, from these tiny little proteins pulling on each other to these big, coordinated systems of levers creating motion, the muscular system is just a masterpiece of biological engineering. Every single day, your body is performing millions of these tiny molecular dances just for you. So the only question left is, what are you going to power with yours?